Howdy, it's tubalcain again, and in this series of videos, and there'll be 5 or more videos, I'm going to show you how to make a double-acting wobbler steam engine. Both of these are wobblers. This is the one that I built in the last series. They can be called wobblers or oscillating engines, steam engines, either one is correct. But when you go to find these videos now, I have 2 different names here. This one is called tubalcain builds a double-acting wobbler steam engine, where the other series is tubalcain builds a single-acting oscillating steam engine. So I changed the names just a little bit so that you could differentiate between the 2 engines and the 2 sets of videos. And go back and watch this series of videos. There's 6 of them there, including plans in the last one, so you can build your own. Some of you have already looked at those videos. There was quite a few views. But this is the one, or a similar one to this. This is my prototype that I'm going to build in this series. I know I'm repeating myself, but the double acting is the one that I'm building in this series. Single acting is the other one. Now the thing I like about a double acting is in general they run a little bit slower and probably have more power if there was a way to test that. Remember that the piston is being pushed down by the steam or the air, and then it's being pushed back up by the steam or the air. And most large steam engines are double acting. I want to say all of them actually. And I'm running this on about 2 or 3 pounds of pressure, and this can be made to run pretty slow, and I like that feature. It's fun to watch. Now there's a spoked flywheel on this one. You probably will not be able to do that unless you buy one, and those are flywheels that I make, and I'm going to use a flywheel like this on the other one that I'm building now too. And you can build your flywheels just like this. This is like 2-inch or 2 1/4 inch cold rolled steel. These holes are too big. That's from another project. The plumbing is a little simpler on the single acting, so there's just an inlet and an exhaust. But we have a little more complicated plumbing on a double acting because we need to supply steam or air to both the top and the bottom. And hence this loop of plastic here, and this is the inlet here, this is the air, and it's being distributed to both. I guess you could call this a little manifold. And those 2 sides there are the exhaust. Now on the one that I'm building now, I believe I'm going to do internal plumbing. And it'll eliminate this. I don't particularly like the looks of that, but I've made a lot of engines in that, that manner. And you know, here's another one that I made long ago, similarly built. This is a lead flywheel. The rest is all aluminum bar stock, a few pieces of brass. Steel piston, and the bore is 5/8 of an inch. The stroke is 3/4. So we have a 3/8 stroke, 3/8 throw, which gives us a 3/4 stroke. Now some of what you're going to see in these videos is a repeat of what I already did, but I'll try not to repeat myself too much, but yet there'll be some new operations in this one as well. And notice that I have fastened the head with screws, and I will use 4 screws on the other one. And we have a bottom piece here that you do not have on a single acting, and that's also held in place with some small screws. And these run a little smoother because this is a guide to the piston rod. So there isn't that business of it wanting to try to flex a little bit. It's guided. Now in a large steam engine, this would be called the packing box or the stuffing box, and there would be some type of packing in there to prevent any leakage I have a pretty good fit here, so there's very little leakage, but I'm sure there is some. There's bound to be some without a packing, but it's just irrelevant in a model engine. So let's get started. Now, what do you need in order to make an engine like this other than a milling machine and drill press and lathes and all of the cutting tools and measuring tools and everything that you'll find in a small machine shop? And some of you are resourceful and can get by with a lot fewer tools, but since I have 5 lathes and you know, duplicates of everything, it certainly makes the job easier. But the idea isn't to get done right away, but to enjoy the journey and consume some of these winter days. And today it is a storm here in Illinois in mid-January. So this is aluminum here, and I got this all at the scrapyard, and I showed that in the last video. And you'll need some brass tubing and other pieces of brass and steel from your scrap box, and that's for the flywheel. And pretty common materials, and you can certainly vary the design to fit what you have. But my idea here is I wanted to be able to make this without castings other than the flywheel, which I like the looks of the spoked flywheel, but you're not going to be able to do that. There are several firms that sell little flywheels. Little Machine Shop does, but theirs are a little bit bigger. I think they're 3 or 4 inch wheels, and this is about a 2.5 or 2 1/4 inch diameter wheel. So we'll start with the base. There's not much to the base. It's just a piece of 1/2 inch thick aluminum. There will be 2 holes in there to hold the upright, and the base is 2 1/4 by 2 1/2 and 1/2 inch thick. And why did I select that size? Simply because the piece that I got from the junkyard was all one, and I cut it in half. So that's how I arrived at that. Notice that I allowed the flywheel to hang over, because there would be interference without making a well for the flywheel. You can move yours in a little bit if you're going to use a smaller flywheel. I've already put layout die on the piece that is going to be the upright, and there's variations. You can make the upright any way you want. This is a little pattern that I made, and that's what I've got here. It's tapered. You could also make it like this and drill little holes in the base, or simply straight up and down like the other one that I made. Actually, it's the prototype here. It's just straight. Or any other design that you can concoct. Now, rather than cut it into this tapered piece to start with, and I ran into just a little problem with making this, it's easier to work with a piece that has straight sides. So I'm going to do all the machining, and then later on I will saw it and mill it so that I have that taper on there. And this is going to be just a little bit shorter. And that can certainly vary also, any way you want to do it. The base has already been milled on 2 sides, so it's squared up. And what I'll do now is saw this and take it over to the mill, and I'm going to mill it, the saw marks off it. I'll mill this too. So I like to have true edges to start with. I've sawed it off, milled both sides, and the size of this piece is roughly 2 inches wide by 3 3/4 long. And the first thing I'm going to do is to drill and tap the 2 holes in the bottom. Now, since this is going to be later tapered like that, I'm going to take all my dimensions and do everything here in my layout from a center line rather than from the edges. So I will find the center line here, scribe it using my height gauge, and then I'm going to put some bluing on the end and draw a center line there and center line there. It'll coincide with that one, and then determine how far apart those two holes will be, and I'm just going to take the measurement off of this. I do not remember. Remember, I don't typically work from plans, but most people do, and certainly you should if you have a set of plans. As usual, my fiendish mascot, the Joker, is present, and he's going to help, and he's got his little ruler in his hand, and he's ready to do a little measuring along with me. And I hope he doesn't harass me during this building. Okay, I've got bluing on the work and on one end, and using my height gauge on the granite surface plate, in soft aluminum, I like to scribe deep enough so there's actually a little bit of a furrow, and you'll see why later on, but that's just my preference. And hold your work up against a 1, 2, 3 block or an angle plate or something so it's perfectly vertical. For some reason or another, this stock, the nominal thickness is a 1/2 inch, but actually it's about 514 thousandths thick. Always measure and double check everything. Measure twice, cut once, the old woodworker's adage. And that's the center line on the bottom for the holes that are to be drilled and tapped. These two holes will be 3/4 inch apart. So on the center line here, I've already center punched that ever so lightly, even though I'm not going to drill there, and I've set the dividers for 3/8, and there are alternate ways of measuring this, but I just scribe a little arc on each side. And then, you know, somebody asked me what this was, and I've repeated it over and over. This is an automatic center punch, Fowler brand, and I have many Starretts. I like this little pocket one best. But I just mentioned to you that I like to scribe a furrow. Now the reason I scribe the furrow is you can literally put the tip of the punch into the furrow and drag it until you get to your layout line, and then you know you're on center. Similarly, not that these need to be that accurate or are that important, but why not work accurately all the way through a project? But don't kill yourself with self-imposed tolerances that are too close, because you will aggravate yourself. Now those are ready to drill. Years ago, back when I was in my prime, I made this little setup here of taps and tap drills and clearance drills. So if you look at this carefully here, I start here at 342, I guess it is, 348, 440, 540, and so on. I work my way up. And in each little row here, I have, for instance here, I've already pulled the tap drill size, 1024, which went in there. It was a 5/32, and the tap is a 1024 taper tap, and these are always ready to go. And it is so handy when I find a dull drill or tap, you know, get rid of it and put a new one in there. I usually keep the smaller tap wrenches in the same little set. I can carry this around to the job, and immediately after I use those cutting tools, I put them back in here so that I got them for the next time, and it saves so much time, aggravation, and makes your workshop a more pleasant place to spend time, without the aggravation all the time of looking for the appropriate ones. Now I'm at my Walker Turner drill press, and I've set the stop so that I'm going to go to the same depth, and it's about 3/4 deep. I like to drill them plenty deep so I don't have to deal with a blind hole, and that the screw isn't going to bottom out on me. That's my 5/32 drilled, and did you notice how I have it held in the vise, with the vise laying on its side? And the reason for that is it reduces the height. And now I'm ready to drill using a little aluminum tap, and I've already pre-drilled those holes on my little precision drill press that I often talk about. those holes aren't going to move on me now. I think you know what I mean by the drill skating and moving off of your layout line. So a good center punch mark, and then pre-drill them with a 1/16 inch bit on a precision drill press, and they're not going to move. In review, those holes were drilled 5/30 seconds and tapped 10/24, and then furthermore I went in with a 3/16 drill, which is a clearance size, just about an 1/8 inch deep. And the reason for that is it helps to get the tap started straight. And I squirted some fluid in there already. Got my vise protectors on. And I'm using a 10/24 tapered tap, and it's very easy to tap a straight hole when you took the double precautions that I just explained. Go in about a half a turn, back it off. Now the reason I tap those holes extra deep is that I will go until the tap bottoms, and be careful you don't break one when you do that, but you will feel it when it hits the bottom. But that way all I have to do is blow the holes out, and I don't have to go in there with a bottoming tap or a plug tap, because the hole is going to be threaded deep enough to accommodate those 3/4 screws. And I'll tap both holes. On the base I have located where I want the upright to be, and in this case it's about 3/8 from the back here. And I laid out 2 lines. Now on this piece the holes again are already tapped, and I inserted transfer screws, and we talked about those a lot of time, 10/24 transfer screws, and they're just barely sticking above the surface. I can feel them with the square. Get yourself sets of these if you don't have them. They come in every size. Then I'm going to transfer the holes onto the base, and I will use my little square. I'm going to put that right on one of the lines. Bring the work right up against the blade, and I'm going to just eyeball equal distance from both sides, because remember later on this will be milled, so that isn't all that important at this time. I'm just going to hold it there, trying not to let it move, but I could use a third hand there. And give her a whack, and the 2 center punch marks are evident there. Now I'll punch them a little deeper, and then I'm going to drill these 3/16, which is the clearance size for these screws, and then I will counterbore it from the back. But since I do not have a counterbore, I'll just use a drill, whatever the appropriate size is for this head size here, so that the holes will be counterbored. The screws will be recessed like that. Now you can use flathead screws, and there's other alternate ways of doing this. Some of you will say, well, you're doing it all backwards. Go ahead and drill these holes first and then transfer them onto this, and that certainly will work as well. So your choice there. Whenever possible, I like to use my little Cameron precision drill press here with a 1/16 bit to do the pre-drilling after I've center punched. That's my MO. You don't have to do that, but it certainly prevents the holes from moving on you. I'm sure some of you are saying, why does he go to all that trouble transferring them? Just lay out the holes here, and then lay out the holes here, and do your drilling and tapping and counterboring and everything. And do that if that is a good way for you. But I just prefer transferring them. I always have, but you can do it either way. Now if you're going to do it on the mill with the DRO, certainly, because you're going to get it within a thousandth, but I'm doing a lot of this in a more primitive way, because there's a lot of guys out there at home that do not have all of these tools. And be sure immediately after doing these operations, get your burrs off. I've got all kinds of these counter bores in the shop, but I never seem to have one that is the right pilot and the right diameter here for the screws that I'm using, so that's why I just drilled these, or counter bored them 5/16 so that the screws will go in there flush. The holes aren't quite flat bottom, but it couldn't matter less for what we're doing here.